Okay, so now looking at this one. So what did I get again? I got 9. So ax plus b. It said ax plus b, and it told me the a is 0.90 or 0.9301x plus the b is 19.401. So which one is that? Which has a 0.93 next to x? That has a negative 0.93. That's not it. That has a 19. That's not it. That has a 0.930 next to x. Beautiful. And a 19.41. So it doesn't matter what order they put the answers in. I know from my calculator who goes next to x. So you don't have to change to a different mode or anything. Does that make sense? We good on that? So the answer is C. On to number 4 we go. A moving firm charges a flat fee, $50. Oh, it's cut off. Okay. So flat fee of $40 plus 35 per. Remember the per always goes with the variable? Remember that? The per always goes with the x. Because x is the number of hours. So if it's $35 per hour, then it's 35 times the number of hours, isn't it? So 35x plus 40, option A. That'll be like a gimme, won't it? Good? I'll move on. Nothing more to do there. Just like that. So the per always goes with the x. Okay, so we got a cost. What is the average cost? That's weird. How do you find the... What if I have 82 and a 91 and an 87 on 3 exams, how do I find my average test score? Add them all up and divide by how many scores? 3, right? So average. Average means what? It means total over number. So if they want average cost, they want total 2.09x plus 3740, right? That's total cost. They're telling me in their words that is total over what? Number of items. What's the number of items? X items over X. Does that make sense? That's how you do average, huh? Total over number of items. And the number of items is X, they're saying. X items. Now, okay, but where's my answer? Well, you're going to have to separate that, 2.09x, into 2 separate divisions. Like that, and then you can cancel those x's. So it's 2.09 plus 3740 over x. It's B. Everybody see that? Really common algebra mistake is to go, oh, I just cancel them right there, and then you just add them up. You can't do that. With pluses and minuses, you can't cancel things. Because of this guy, he says no. Pluses and minuses is like shopping at Costco. You know what I mean? You go to Sam's Club, Costco, those warehouse stores. You know, that's where my wife shops. We have 5 kids. They sell in bulk there. So if you go in there, you grab one milk, you pull it out, it's plastic to another one. You can't take your scissors to Costco and just break the plastic. Say, thanks, I just want 1 milk. They will not sell you 1 milk. It's buy in bulk, a little cheaper, right? Well, that's what pluses and minuses are like in algebra. Pluses and minuses package things together. You can't break that package. Times, no problem. Who cares? Break it all day long. But when you see this plus, this is what I tell my calculus students, my trig students, pre-calc students, algebra students, plus signs or minus, same thing. They glue it together. So this is glued to that, and I can't break that bond. But when I get, so what I do, I separate it into 2, right? Because that bar is, that x is under both of them. So separate it into 2. Now, this is 2.09 times x. See right here, it's just times. So you can do that, no problem. No problem breaking a times. 2.09. You just cancel these and they're gone. So it's just 2.09 plus 3740 over x. That makes sense? You have to separate them before you can cancel. It's the laws of algebra. Why did they make laws, weird algebra laws like that? Just to give me a job and to torture future. No, it's just what's true. Math, it's always was. Just think about numbers for a minute. If you had 2 plus 6 and divide by 2, well, what is that really? Isn't that 8 over 2 really? Isn't it really 4? 8 over 2 is 4. That's really 4, right? See how illegal it is to do that? Then it's 6. That's not right. See how that's just not true? It's just simply not true. That's really 8 over 2. That's really 4. If I do that, I suddenly made it 6. Not true. Just not so. That's proving you can't, with pluses, you can't cancel one of them. They're glued together. Now, if it was times, are you saying, Mr. Heron, that if it was times, that'd be okay? It's exactly what I'm saying. That'd be fine. Look at it. What is it really? 12 over 2, right? Which is really 6. See how it's really okay to do that? It's just what's true. It's just what's true. So pluses and minuses, Costco glue. Don't ever cancel. They're a package deal. When you see plus or minus up here, he says, you buy all of me or you buy none of me. I'm a package deal. You say, no, I just want the X part. All or nothing with pluses and minuses. Package deal. So we separate it into 2 packages, and then we can shop at Save Mart. We can buy just one right there. It's fine. Times is shopping at Save Mart. You can buy just one. There it is. All right. We better move on. I'm making that too long. We got many more problems. Okay, so that was number 5. Number 6, new car, purchased $14,400. 3 years later, it went down in price, right? Cars do that. Assume that the depreciation in value, linear equation. So this is the 3rd time we've dealt. As soon as you see those words, you think, oh, you mean they're talking x1, y1, x2, y2? Absolutely. Absolutely. This is the 3rd time we've had a linear equation problem. It's that same thing again. It's just at the very end, they want you to plug in and get a final answer instead of just an equation. But we're going to have to first get the equation. So this is like linear with a cherry on top. We got to do one more step at the end. After we get the equation, we got to plug into it. Does that make sense? Let's do it. So what's my x1, y1, x2, y2? Remember what I said? They always make x. X is always time. X is always time. So go ahead and do that. This one's slightly more. What is new? New car. What time is that? How old is that? 0. New car is 0 years old, right? That's telling you, new is telling you x is 0. Everybody see that? New car is 0 years old. So that means this is 0, comma, 14,400, and this one is 3 years old, 8,700. See how I got those two? Time is always x. In this case, it's years old, and then the y is the value of the car. There, and now you know what to do, right? The 2 m equations. So we go, all right, m is y2 minus y1 over x2 minus x1. So y2, 8,700 minus y1, 14,400 over x2 minus x1, 3 minus 0. And minus 1, 2, 3. Minus 5,300 over 3. You could divide it. I said I would just leave it, huh? Let's just leave it. I'll just leave it like that. You could divide it. Might be a little easier, but whatever. Just leave it. So there's my m. Now you do the m equation again, right? M equation one more time. One more time on the m. So now we go m is y minus blank over x minus blank. Grab that, put it in for m. Minus 5,300 over 3, y minus blank, x minus blank. Okay, what am I going to put in the back of x and y? There's x, there's y. So 0 in the back of x, 14,400 in the back of y. We good there? Same kind of thing we've been doing, right? And then diagonal, diagonal, cross multiply. Is that good? Same kind of process we've done 2 times on the practice exam and 1 time on the quiz today. This is our fourth one. So I'm going to move to a fresh screen if that's okay. So minus. It'll be all on YouTube later if I'm going too quick. You can slow it down and watch it over and over again. You can entertain your friends and family. Have them all over to the house. Popcorn, watch Mr. Heron's Math 21 lectures. Okay, diagonal, diagonal. Minus 5,300, x minus 0. 3, y minus 14,400, distribute, minus 5,300. X, forget about the 0, that's nothing, equals 3y minus, what's that? 14,400, it's 43,200. Okay. Now, usually we get y alone, so let's just go ahead and do that. That's normally what we do, and that's a good plan. So get the y alone. Question so far? Is this making sense?
You put 53, it's 57.
Oh, did I mess something up? What did I do?
You said negative 53 should be
That's
57.
negative 57.
Oh, shoot.
50, yeah.
Because you put 14,000 and
Yeah.
14,400.
Yeah, you forgot to a 4 right there instead of it being
Doesn't matter,
14,000.
it's fine.
Where is it I messed up?
On the negative 53,000 equals y minus.
Yeah. Where is it? Right here?
Yeah, it should be 57.
50. Why is it 57? I'm not seeing why.
Oh, because you
it's
multiply.
400, not 14,000.
Yeah. The 1870.
Oh, I forgot this.
Yeah.
Is that what you're saying? Oh, thanks. Shoot. So 5,700? 57. Is that what it is? Oh, going too fast for myself. Yeah, thanks. 57. Thank you. No, that's important. Thanks for correcting that. Bring it down here, here. Yeah, good. Thank you. And then add the. Is everything 14,004? I have it right now, right? Yeah. Okay. So now add that 43,200. We get to there, and divide by the 3. Hopefully that's a nice number. Minus 1,900x plus, what's that one? 14,400. Oh, yeah. Equals y. Okay, we got the equation. Now, we're not quite done yet. Here's where we have the cherry on top. One more step. So that's all. That's the normal thing we do on all the other linear ones, right? Get the x1, y1, x2, y2, the m formula twice, get y alone. There's our equation. But they're asking us for more than the equation now. Let's go back. What do they want? They say 4 years. They want the value of the car at 4 years. Remember, that's x. Time is always x, huh? Time is always x. They're saying, hey, when you get that equation, stick a 4 in for x. So I take this equation now, and I say, okay, put in a 4 right there. So this, I'll bring it over here. This becomes minus 1,900 times 4 plus 14,400. Everybody see that? 1,900 times 4, which is minus 7,600 plus 14,400. And I'm getting 6,800. So the car's worth 6,800 after 4 years. That's what this formula is. You plug in the number of years old, it'll tell you how much the car's going to be worth in the future. Like how much is it going to be worth in 10 years, 20 years? You just plug into that formula. Assuming that it continues linearly. We assumed it was a line, linear depreciation. So the car would be worth 6,800. So we did all the work of finding the equation, just like the other ones, and then at the end plugged in 4 for 4 years old, because they said X is 4 years old. So 68, is it not there?
It's not there.
After all that work?
Yeah.
Oh, that's disturbing. All right. None of the above. But we're confident, right? Won't shake you, maybe. No, that was a lot of work. Yeah, to not have your answer there. Questions on that one?
Can you do number 13?
Yeah, that's
What's that, 13? You want to make sure we get 13? Yeah, get nervous. We're not, Mr. Let's see, but if I start running, I'll make sure I'll get to 13 for sure if I start running out of time. All right, so I'll try to go a little quicker here. Lumberyard, fixed cost, 74, 30, 40. And variable, that means that's the one that goes with the variable. 1x plus the fixed. That makes sense? The variable one goes with the variable. The other one is just fixed per board foot. That's the cost, okay? The company gets, that's, what do you call that? Revenue. They usually call that revenue. Right? Revenue is 280 per, what does per always mean? There's an x there. The per always means you get an x with it, just like we did a minute ago on the per one, right? They get 280 per board foot sold. So in other words, however many board feet they sell times 280 each is the money they take in, the revenue. Call it whatever you want. You don't have to call it R. Whatever you want. That's the income. That's money coming in. The cost is whatever that was, 7,430. That's 0.40. That's just to run the mill every day, just to pay the employees and to pay the electric bill for the shop and all that kind of stuff. That's a fixed one-time cost plus $1 times X, and that was $1 per board foot. That's their cost on the lumber, which is lower, right? That's how they make profit. They sell it for more than it's worth, but they have one-time costs. So they're basically saying equilibrium. What does equilibrium mean? Equal. set these things. You want 1x plus 74, 30, 40 equal to, and just solve for x, 280x and solve for x. So they want you just to, because when incoming and outgoing are equal, you're in equilibrium, right? You're breaking even. That's what equilibrium means, breaking even. Set cost and revenue equal. So solve that equation. How do we solve when you got x on opposite sides? You get rid of the lower one. Subtract 1x from both sides. I get 74, 30, 40 equals 1.80x. Last step to solve for x, divide by 180. 180, hit the buttons on your calculator, whatever that is, 74, 30, 40. Is that what it is? Yeah, 4128. 4128, D. Number 8. Is this linear, quadratic, or exponential? X squared is quadratic. That's when you have x squared. Exponential, what would that look like if it was exponential? X is up in the power zone on the top, yeah. Linear, you know linear, that'd be, mx plus b kind of thing, right? Okay, so one of those is on the exam. I don't even know which one. We'll keep moving. Okay, blah, 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 blah. This equation. N is the number of filtering steps. Find the amount for n equals 5. So basically saying plug in 5. That's just a bunch of blah, 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 plug in 5. Do y'all see that? Right? N is the number, n is 5. Plug in. So I'm going to take 500 times 2 to the minus 0.4 n, and then I'm going to put 5 in right there. So it'll become 500 times 2 to the minus 0.4 times 5. So can you enter that in your calculator, basically? And so remember now, when you enter it in your calculator, anything in a zone needs to be put in parentheses. What do I mean by zone? Top of a fraction, bottom of a fraction, or power zone. So this needs to be parenthesized, doesn't it? Because it's two things in a zone. If you have more than one thing in the top of a fraction, bottom of a fraction, or power zone, you got to parenthesize. Otherwise, the calculator won't know it's all in the same zone. So 500. I'm getting 125. D. Good. If you have any trouble with that in your calculator, come see me. Right after, to take 10 seconds after class. Be glad to help. Halfway through. All right, number 10. Blah, blah, blah. 1920, it was 76.3. 2005, it was that. Oh, but this is not linear. It's exponential. It's one of these. These are hard. All right, so number 10 is hard. It's an exponential. So they're saying this mortality rate thing, it's not getting better. It's actually going down. The mortality, people are, the more kids are surviving. Infants are surviving. It's getting, the rate of survival is going up, but not linearly. Even better, exponentially. Like it's going up like this, which is great, right? The medical science improvement is making infants survive birth way more, exponentially going up, not linear growth, huh? So because it's exponential, you understand what we're doing, guys? You're getting you can miss the forest for the trees. Real life things sometimes happen linearly, grow like a line. Sometimes real life things grow like an exponential curve, or other curves also. And so that's what we're doing. They look at real life data and they go, hey, we've been, what they would do in real world is they would get some dots and they go, hey, these dots are going like an exponential curve. So let's come up with an exponential function that fits the reality that we're seeing, and then let's predict 10 years from now where we're going to be at if it continues to follow that trend. See what we're doing? Sometimes trends are linear, sometimes trends are exponential, and there's other things too. But on this test, we're just dealing with linear and exponential. Exponential is much harder, isn't it? So there's the exponential equation. P equals P0 b to the t. So here we go. Remember what the P0 always means in all these formulas. What does a sub-zero mean always? Start. Yeah, that's at time zero. That little zero means P at time zero. It's one thing. It's not two, right? P0 is whatever P is at time zero, initially, at the start. Well, it says in 1920, the infant mortality rate was 76.7, that many deaths. And by 2005, it had gone way down. So, they're keeping track of deaths, right? So we're starting, they're saying let T equals 0 be 1920. So that's our P0, isn't it? That's our starting time. It's the 76.7. That's the starting infant mortality rate. B to the T is P. Okay, now remember how these ones always work. They're in two phases. So phase one is you get your B. You got to find your B, your base. And then phase two, you start over again and finish the problem. So let's do this. So they're telling me that in 2005, so what's the time if 1920 is the starting, T equals 0? Oh yeah. So if 1920 is the starting, then 2005, how many years later is that? 85 years. 2005 minus 1920. So that's 85 years later. So 85 years later. So if I plug in 85 for time, plug in, 85 for time. The mortality rate in 2005 was 6.9. So the P is 6.9. So 6.9 is 76.7 B to the 85. And I can solve that for B. Does everybody see that so far? See what I did there? So I took the basic equation they gave me, put in the initial infant mortality rate, 76.7. Then I said, how many is 85 years later? It had dropped to 6.9. So 6.9, 85 years later. So that allows me, phase one, remember, is all about getting your hands on B, finding B. Now, how are you at solving that kind of thing for B? What do we do first? We divide by 76.7. And I would just leave that fraction like that. So now I have 6.9 over 76.7 equals B to the 85. Good so far? So, in fact, I really need a fresh screen, I think, here. What number is this? This is number 10. Phase 1. P is P0, B to the T. So, what was it? 6.9. 76.7 B to the 85. Divide by 76.7. Okay, so 6.9 over 76.7 is B to the 85. Okay, so what do we do now to make it regular B? Yeah, do you remember that? Good job. 1 over 85. 1 over 85. Boom. That does it. So B is 6.9 over 76.7 to the 1 over 85. I want to do that in your calculator real quick. So 6.9 divided by 76.7 to the power. Remember, you got to put parentheses around that power because there's more than one item in the power zone, right? Parenthesize that 1 over 85 in the power. And I'm getting 0.97206. How far should you go? I don't know. That's probably far enough. That's 5 decimal places. That's plenty. 5 or 6, 5 or 6, whatever. Good so far. So we got B. Now phase 2. Phase 2, you start with the same formula again. But now, you've already known P0. Now you know B. 0.97206 to the T. Phase 2, use your B. So phase 1 is get B. Phase 2 is use your B. Everybody see what I'm doing now? Now, to do what? What's their final question? 2020. Find the so they're projecting into the future. What's the infant mortality rate going to be in the year 2020? Well, 2020, we started this thing in 1920. So year 2020 minus 1920, that's 100 years. So they're saying T is 100. They're saying, hey, we want you to take 100 and plug it in right there. Tell us what the infant mortality rate will be if medical science keeps improving infant mortality rates at the same speed. You'll plug in 100. So use your calculator. I'm getting 4.51. Is that one of the answers? Yeah, B. Bless you. Is that good? You good with that? That's a hard one. That's certainly like an A kind of question. Separating A's from the B's, probably that one. It's tough. 2 phases. You put that whole thing in your 3x5 card if you want. Might use up a big part of your real estate there, but feel free. You know, do anything you want. Write a whole example. This one, if you're good with everything else, but this particular one's getting you, put the whole thing on your 3x5. I better move on. Okay, so 12 log base 8, 69.09. You make it 2 logs. The higher one up goes higher, the lower one down goes lower. Make it 2 logs, hit the buttons on your calculator. Number 13. It specifically says let P be 5. So basically you just make this left side 5 like that. It's kind of weird. I know it's weird the way they put like a percent symbol there because you kind of want to make it 0.05. That's why specifically, this is their problem. You're going to get these off the publisher's web, but I added this parenthesis note because I thought it was kind of awkward, their problem. So I'm letting you know. Just put a 5 over there for P. It's kind of weird. But okay, got to solve for H now. Now how do we solve that for H? So the whole problem becomes solving for H. What's my first step? Add the 80, right? Add the 80, boom. 85 is 10, natural log H. Next step, divide by the 10. So 8.5 is natural log H. Are we good to there? We're not done yet. We're good to there, right? 8.5 is natural log H. Okay, let me come up here now. Let me erase this, and let me talk to you. I've got a new way to say this. I was working with Joel and maybe a couple other people the other day in my office hours, and I thought after they left how I'm not being as, there's a better way to say this, a way that's more helpful, I think. Think with this way with me, because I try to help you remember these steps. If you remember from algebra, if you're trying to solve like x squared is 9 or whatever, what do? You root it, don't you? Because rooting gets rid of squares, right? And then likewise, if somebody gives you like a different equation, they go, hey, I've got the square root of x is 2 or whatever. What would you do to get rid of that root? Second power. So my point is, and they get rid of each other, don't they? And that'd be 4, and this would be 3. My point is, roots and 2 powers are opposites. You know that from algebra, huh? Well, so are e's and natural logs. That's what I want to show you. So let me say that again really slowly. Just like a square root and a second power are opposites in the world of algebra, so that if you happen to see one of them, you bring in the other. It's like an acid and a base. They neutralize each other, or a poison and the antidote. They neutralize each other, right? That's how it works in algebra. If you have a square power, you could bring a root and it cancels it. Or if you got a root, you bring a 2 power. If you got one of them, you bring the other. And they cancel each other out, don't they? Well, that's how natural log and e to a power work. They're opposites. Just like log and 10 are opposites. Are you aware of that? Let me write that up here. So ln and e to a power are opposites. So meaning, if you're dealing with some equation, you got an ln, you want to get rid of it, put an e underneath it, e to the power it. And log and 10 to a power are opposites. They undo each other. They cancel each other. I said it last week, base is a base, other two switch. That's if you got that and you're good with that, right, that's true also. So let me say it both ways. So bring it up here. So we've got what? We've got 8.5 is ln h. What am I trying to do? I'm trying to get rid of that ln because I want to get h alone, right? They asked me to solve for h. How do I know they said that? They said, what altitude? And altitude is h, they said somewhere. Here, altitude is h. They said, what altitude? Altitude is h. So they're saying, what is h? Aren't they? So how do I solve for h? You see this, you can just go e, gone. Does that make sense? E to a power. I just e powered both sides. And it gonzo, so it's just h. That got h alone. E to the 8.5, type that into your calculator. E to the 8.5. And I'm getting 4914.7. Yes, none. Another one of none. So does that make sense what I did there? Now, the other way, if you're thinking, Mr. You told us the other thing. Yeah, I can go back to it the other way too. I said, hey, whenever you want to get rid of a log, this is the other way I said it, and that's fine too. It has a base down here, doesn't it? Every log has a base. ln has e. Lose the log, base stays the base, other two switch. Instead of e to the h, it's e to the 8.5. H goes over here. Same result. Same thing, I'm just giving you another way to see it. E and natural log are opposites. So if you got one of them, bring in the other. Just like log and 10 are opposites. Is that good?
Those metal above are kind of killer.
Yeah, I know, they're disturbing, aren't they? They're testing you. Super tricky?
Maybe
20.
20.
16,000.
16, 20. Okay, let's do these quick. So, log rules. Got to take this 2 and put it up there. Remember, front numbers go to powers. Becomes w squared. 7 goes up here. Times z to the 7th. Because adding becomes a harder job for one log. Over, subtraction becomes divide. X minus 5. There we go. Is that answer A? Looks like A to me. So you just do that. This one's tricky because he's got two z's. So natural log of square root of fz minus natural log of z cubed, right? Because dividing becomes subtraction. If you're not aware of this, check back with those rules. I'll be glad to help you further offstairs. So here's the other trick. Square root is a half power. That's pretty tricky. Do you remember that from algebra? Did you see that? Square root of anything is that anything to the half power. That's a trick from algebra. They assume you know that, but I know that's not easy to remember. Square root on something means that thing to the half power. So what? Why do I care? Well, because then that power can come to the front. Remember log rules, the powers come to the front? So this becomes half ln fz, and then the 3 comes down here. And right here, we might think the answer's A. I did in my office at first. But then Joel slapped me around. He said, no, Mr. Heron, it's not A. And he's right. There's a Z here and there's a Z there. We got to combine those somehow. How? Let me bring it up here and I'll finish it up. The trick is now what are these? Just look at this part all by itself. What if you just had ln of fc, nothing else? Those are timesed. So it becomes adding for two logs, doesn't it? So it's a half ln f plus a half ln z minus 3 ln z. Do you see that? Because this is times, remember? Times becomes adding for two logs. And they both have the half in the front, remember? That little operation, times becomes adding. Check out those log properties. Okay, now, these guys are like terms. This is like saying half of $1 minus $3. They're both L and Z. Half an L and Z minus 3 L and Z. Let's say I got a half $1 and I lost $3. Where am I at? I'm down $2.50. L and Z. See how I just combine these guys? Half an L and Z, take away 3 L and Z's is minus 2.5. 2.5, or if you want, 2.5, same thing. And then, see, that's the answer right here. They made it 5 halves. They just multiplied 2 times 2 is 4, add 1 is 5 halves. There it is. You see that? That's kind of tricky, isn't it? Did I go too quick on that? Look at the YouTube later. I better move on. 16, okay, we're using the formula A equals P1 plus RT. That's the formula here. They're telling you 14 computers at $2,500 each. 14 times $2,500, what is it, 35,000? I thought, yeah, thank you. Well, you plug that in for the A because that's the amount they need to have in 5 months when the computers show up to pay the bill. The principal is what they're going to put in the bank now. The interest rate is 0.0732, that's the R. The T is 5/12 of a year, 5 months. Everybody see that? And then you got to solve for P. They want to know what principal do we put in the bank today that'll become that 35,000 in 5 months. So you just divide by the whole 1 plus 0.0732, 5/12 divide by the 1 plus 0.0732. 5/12. Bonk. Hit the buttons on your calculator. 17 is easy for you, I think. I'm going to move on. Record here. Okay. E, 4e to the 6c. Oh, it's all in the power, huh? Plus 2 is 5d. They want me to solve for c. There it is. That's the one we got to get alone, huh? So how do we get that thing alone? Well, first step is get rid of that 4. Boom. E to the 6c plus 2 is 5d over 4. Now, we got an e, right? We want to get rid of that e. Remember what I was talking to you about? What's the opposite of e? ln. Is that working better for you now? I'm hoping. So if you got e, you use ln. You got ln, you use e. They undo each other like a square root and an x squared. So I see that and I go, oh yeah, I got to get rid of that. So let me just ln both sides. Boom. Gone. So 6c plus 2 is ln of 5d over 4. Is that easier thinking that way? They're opposites. E and ln. Just like 10 and log are opposites. E and ln are opposites. Now it's easy. Just move the 2 over. Subtract the 2 from both sides. ln of 5d over 4 minus 2 and divide by the 6. Hopefully it's there just like that. Is it A? Yeah. Good. Number 19. Solve for S. Oh, it's got a log. It's got a log. I'm gonna move on if that's it. 19. So 4 minus R is log 9S plus 7. Okay. Trying, where's the ball? It's S. Trying to solve for S. Here it is. Okay, if I got to solve for S, I got to get rid of that log. What's the opposite of a log? 10. Because that's his base. So if you see it, you go, oh, that means 10 to the power. Logs are the reverse of powers. That's what they are. Log is the reverse of a 10 power. ln is the reverse of an e power. So it's not just, let me be clear here. It's not just multiplying by 10. Notice what I did not do. Maybe this would be helpful. I didn't just stick a 10 like times it or something. No. I put the 10 down as the base and made it a big power thing. Right? 10 to the power, 10 to the power. Because logs are the reverse of powers. That's what they are. They're inverse functions of power functions. They're inverse exponentials is the technical term. So yeah, so you got ln, use e. You got regular log, use 10 because that's his base. To both sides. Cancels it here. Other side it stays. Does that make sense? And now just move the 7, subtract the 7 over. Like that, and divide by the 9. Boom. There it is. 10 to the 4 minus R minus 7 R. Is it B? Yeah. Looks like B. Finally, your favorite, number 20. We got an E. So with that one. So number 20, bring it up here. 4e to the 2x plus 6 equals 20. You first have to get the baseline. Before you do this kind of stuff, you got to, trying to solve for x, you got to divide by that 4. Boom. E to the 2x plus 6 is 5. And what am I going to do to get rid of that e? ln. Getting the hang of this? Yeah, there's like 3 or 4 of these. We got an e, you do an ln. You got a log, you do a 10. And vice versa. So I'm going to say, okay, I'm going to ln. Now that just goes on the level. Right? The logs we put on the level. If you bring in an e or a 10, you put them in as a power setup. Cancels. So I get 2x plus 6. ln 5, just move that 6 over. That 6 is going outside the log, though. And so it's out there, divided by the 2, right? ln 5 minus 6. Oh, and then you got to hit the buttons, huh? Now remember, it's like this. That 5 is plugged into the ln function, plugged into the toaster. The 6 is subtracted outside of the ln. Don't put that 6 into the ln. He's subtracted off to the right. So we get ln of 5, and then subtract the 6 afterwards and divide it all by 2. And remember, you got to put parentheses around the whole numerator whenever there's more than one thing in the zone. So I'm getting negative 2.19. Oh, none of the above. Negative 2.195, yeah. None of the above. Disturbing for the last one. All right, there we go, guys. We're done. It'll be just like this. The real exam will be just like this. Same amount of problems, same amount of each type of